For the 2009 free response questions for part A, we need to use Euler's method to approximate f of 0. The first thing we need to do is write down the given information, which is dy over dx is equal to 6x squared minus x squared times y. The second thing we need to write down is f of -1 is equal to 2. Once we have that written down, the next step is to find out the two steps of equal length. And to do that, we divide -1 by 2, and then we get -1/2. The next step is to find f of -1/2. To find f of -1/2, we set that equal to f of -1 plus dy over dx at the point -1, 2 times the change in x. We are given f of -1, and that is equal to 2. So we add 2 plus dy over dx at -1, 2, and then we multiply that by the change in x, which is 1/2. Once we get through with the plugging in of the point -1, 2, we end up with 2 plus, in parentheses, 6 minus 2 times 1/2. Once we subtracted 2 from the 6, we get 2 plus 4 times 1/2, and that is equal to 2 plus 2, which equals 4. We then use what we found for f of -1/2 to approximate the value of f of 0. So what we do is use the Euler's method's formula, and we set f of 0 equal to f of -1/2 plus dy over dx from the point -1/2, 4, and we multiply that by the change in x, which is 1/2. So we know what f of -1/2 is, so we plug in 4, and we add to that dy over dx from the point -1/2, 4. We multiply that by 1/2. So we end up getting 4 plus 1/2 times 1/2 is equal to 17 over 4. And that is our answer for part A. For part B, we need to find the second degree Taylor polynomial for f at about x equal to 1. The first thing we do is write down what is given to us. We know that the second derivative is equal to -12. Once we have that written down, what we do is we write down the formula for Taylor series polynomial, which is f of a plus f prime of a over 1 factorial times x minus a plus f double prime of a times x minus a squared over 2 factorial. A in this case is -1, so we substitute for a -1. So we end up getting f of -1 plus f prime of -1 over 1 factorial times x minus -1 to the first power plus f double prime of -1 times x minus -1 squared over 2 factorial. We know what f of -1 is. It is equal to 2. So we plug in 2. Once we plug in 2, we are given the formula for f prime. So we plug in the point -1, 2 into dy over dx. And from there, we get 4. I accidentally wrote 2, but it's supposed to be a 4. So it should say 2 plus 4 times x plus 1 plus f double prime, which is also given to us, and that equals -12. So we write -12 over 2 factorial times x plus 1 squared, and that is equal to the second Taylor degree polynomial. But I decided to go ahead and simplify, so the final answer should say 2 plus 4 times x plus 1 minus 6 times x plus 1 squared. For part C, we need to find the particular solution for y equal to f of x. The first thing we do is write down the given information, which is dy over dx is equal to 6x squared minus x squared times y. We are also given f of negative 1, which is equal to 2. Once we have that information down, the next step is to do separation of variables. And to do that, what we need to do is get all the y's on one side and all the x's on the other side. So we do that by multiplying both sides by dx and dividing both sides by 6 minus y. So then we get 1 over 6 minus y times dy is equal to x squared times dx, and we integrate. So then we end up getting negative ln of 6 minus y is equal to 1/3 x cubed plus c. The next step is to find c, and to find c what we need to do is plug in the given points, which is negative 1, comma 2. Once we plug that in, we end up getting negative ln of 6 minus 2 is equal to 1/3 of negative 1 cubed plus c, and then we get negative ln of 4 is equal to negative 1/3 plus c. Then we add ln of 4 to both sides, and we get c is equal to 1/3 minus ln of 4. Once we have our c, we plug that into the original equation we had found earlier, and we end up getting ln of 6 minus y is equal to negative 1/3 x cubed minus, in parentheses, 1/3 minus ln of 4, close parentheses. Then what I did is I distributed a negative 1/3 out, and I ended up getting ln of 6 minus y is equal to negative 1/3 in parentheses x cubed plus 1 plus ln of 4. But what I did is I subtracted ln of 4 to both sides, and I ended up getting ln of 6 minus y over 4 is equal to negative 1/3 times x cubed plus 1. The next step is to raise both sides by the power of e. Once we have that, the ln of 6 minus y over 4 cancels out with e, and we end up getting 6 minus y over 4 is equal to e to the negative 1/3 in parentheses x cubed plus 1. And to get 6 minus y on its own, we multiply both sides by 4, and we end up getting 6 minus y is equal to 4 times e to the negative 1/3 times x cubed plus 1. And then we subtract 6 from both sides, and then we get negative y is equal to 4e to the negative 1/3 times x cubed plus 1 minus 6. We then divide both sides by negative 1 to get y to be positive, and we end up getting y is equal to 6 minus 4e to the negative 1/3 times x cubed plus 1.